Romex is not abbreviated as NMB. The circular mills of Romex depend on the size of the wire. The National Electrical Code, or NEC, only requires conductors in a raceway to be grouped together in a compact arrangement. Furthermore, not more than 40% of the cross-sectional area of the raceway is to be occupied. Based on these requirements, a maximum of 9 14-2 Romex conductors may be run through a 1 and 1/2 inch hole. It is essential to understand the principles behind these limitations to ensure safe and compliant electrical installations. Firstly, conductor fill limitations are primarily aimed at preventing overheating. When multiple current-carrying conductors are bundled together, the heat generated by each conductor cannot dissipate as efficiently as it would if the conductors were individually spaced. This heat buildup can lead to insulation degradation, which can ultimately cause short circuits, ground faults, and even electrical fires. The NEC fill requirements are designed to maintain the temperature of the conductors within their rated limits, ensuring the long-term reliability and safety of the electrical system. Secondly, the concept of circular mills is crucial in determining conductor ampacity and fill requirement. A circular mill is a unit of area equal to the area of a circle with a diameter of 1 mil, or 1/1000th of an inch. The circular mill area of a conductor is directly related to its current carrying capacity, or ampacity. Larger conductors with greater circular mill areas can carry more current without overheating. When calculating conductor fill, the total cross-sectional area of all conductors in a raceway or hole must be considered. This is typically done by summing the circular mill areas of each conductor and converting the result to square inches. The NEC specifies maximum fill percentages for different types of raceways and installations, ensuring that the heat generated by the conductors can be adequately dissipated. Thirdly, the 40% fill rule for raceways is a common requirement in the NEC. This rule limits the total cross-sectional area of conductors to 40% of the internal cross-sectional area of the raceway. The remaining 60% of the area is intended for airspace, which allows for heat dissipation and facilitates pulling conductors through the raceway. While the 40% fill rule is generally applicable to raceways, the specific requirements for conductor fill in holes may vary depending on the local electrical codes and the authority having jurisdiction. It is always recommended to consult the relevant codes and regulations to ensure compliance. In the case of running Romex cables through a hole, the primary concern is heat dissipation. Romex cables typically consist of 2 or 3 insulated conductors surrounded by a non-metallic sheath. The sheath provides mechanical protection for the conductors and helps to contain any potential arcing or sparking. However, the sheath also acts as an insulator, which can impede heat dissipation. When multiple Romex cables are run through a small hole, the heat generated by the conductors can become trapped, leading to overheating. The NEC does not explicitly address conductor fill for holes in the same way it does for raceways. However, the general principles of heat dissipation and conductor ampacity still apply. A common rule of thumb is to limit the number of Romex cables in a hole to a point where the cables are not tightly packed and there is sufficient airspace for heat dissipation. In a specific scenario of running 14-2 Romex conductors through a 1 and 1/2 inch hole, a maximum of 9 conductors is generally considered acceptable. This is based on the assumption that the conductors are arranged in a compact manner and that there is adequate airspace around the cables. However, it is important to note that this is just a guideline, and the actual number of conductors that can be safely run through the hole may vary depending on the specific installation conditions. To determine the appropriate number of conductors, consider firstly the ampacity of the conductors. The ampacity of 14-2 Romex is typically 15 amps, as dictated by the 14-gauge wire. Ensure that the load connected to the circuit does not exceed this ampacity. Secondly, consider the ambient temperature. Higher ambient temperatures can reduce the ampacity of conductors. If the hole is located in a hot or poorly ventilated area, it may be necessary to reduce the number of conductors to compensate for the reduced ampacity. Thirdly, consider the length of the hole. Longer holes can restrict airflow and impede heat dissipation. If the hole is particularly long, it may be necessary to reduce the number of conductors to prevent overheating. Fourthly, consider the type of insulation. Some types of insulation are more resistant to heat than others. If the Romex cables have a high temperature insulation rating, it may be possible to run more conductors through the hull. In addition to these factors, it is also important to ensure that the Romex cables are properly supported and secured. The cables should be supported at intervals of not more than 4 and 1/2 feet and within 12 inches of any box or fitting. This will prevent the cables from sagging or straining, which could damage the conductors or insulation. Furthermore, the cables should be secured to the hull using appropriate cable ties or clamps. This will prevent the cables from moving or rubbing against the edges of the hull, which could also damage the conductors or insulation. When drilling the hull, it is important to use a drill bit that is the correct size for the Romex cables. The hull should be large enough to accommodate the cables without forcing them, but not so large that there is excessive airspace. Using a drill bit that is too small can damage the cables, while using a drill bit that is too large can reduce the effectiveness of the cable supports. In addition to following the NEC guidelines and considering the factors mentioned above, it is also important to exercise good judgment and common sense when running Romex cables through holes. If you are unsure about the safety or compliance of an installation, it is always best to consult with a qualified electrician. A qualified electrician can assess the specific installation conditions and provide expert advice on the appropriate number of conductors, the proper support and securing methods, and any other relevant safety considerations. Furthermore, it is crucial to remember that electrical work can be dangerous, and it should only be performed by qualified individuals who are familiar with the relevant safety procedures. Working with electricity can result in serious injury or death if proper precautions are not taken. Always energize the circuit before working on any electrical equipment, and use appropriate personal protective equipment, such as insulated gloves and safety glasses. In summary, determining the number of 14-2 Romex conductors that can be safely run through a 1 and 1/2 inch hole requires careful consideration of several factors, including the ampacity of the conductors, the ambient temperature, the length of the hole, the type of insulation, and the NEC guidelines. While a maximum of 9 conductors is generally considered acceptable, it is important to assess the specific installation conditions and consult with a qualified electrician if necessary. By following these guidelines, you can ensure that your electrical installations are safe, compliant, and reliable. Additionally, always consult with the local authority having jurisdiction, as they may have more stringent requirements than the NEC. They can provide clarification on local interpretations of the code and any amendments that may be in place. By doing your due diligence and staying informed about the latest codes and regulations, you can ensure that your electrical work meets the highest standards of safety and quality. It's also important to remember that electrical codes are constantly evolving to address new technologies and safety concerns. Regularly updating your knowledge of the NEC and other relevant standards is crucial for staying ahead of the curve and providing the best possible service to your client. Many organizations offer continuing education courses and certifications that can help you stay up to date on the latest electrical codes and best practices. Investing in your professional development is a worthwhile endeavor that can enhance your skills, increase your earning potential, and improve the safety of your work. Consider also the future needs of the electrical system when determining conductor fill. If you anticipate adding more circuits or increasing the load on existing circuits, it may be wise to install a larger hull or raceway to accommodate future expansion. This can save you time and money in the long run by avoiding the need to rewire the system later on. Finally, always document your electrical work thoroughly. Keep records of the materials used, the installation methods employed, and any deviations from the NEC. This documentation can be invaluable for troubleshooting problems in the future and for demonstrating compliance with electrical codes. Good record-keeping practices can also protect you from liability in the event of an electrical incident. Remember, safety is paramount in all electrical work. By adhering to the NEC guidelines, considering the factors mentioned above, and exercising good judgment, you can ensure that your electrical installations are safe, reliable, and compliant. When it comes to the question of how many 40-2 Romex conductors can be run through a 1 and 1/2 inch hole, a general guideline is that 9 conductors are permissible. However, as discussed, this number is subject to various factors that must be considered to ensure safety and compliance. Let's further elaborate on some practical considerations and best practices for this scenario. Firstly, when drilling the hole, ensure it's a clean, smooth hole, free from burrs or sharp edges that could damage the Romex cable sheathing. Use a proper hole saw or drill bit designed for creating smooth, round holes in wood or other materials. Secondly, when pulling the Romex cables through the hole, avoid excessive pulling force that could stretch or damage the conductors or insulation. Use a lubricant specifically designed for pulling electrical cables to reduce friction and prevent damage. Thirdly, after the cables are pulled through the hole, inspect them carefully for any signs of damage, such as cuts, abrasions, or kinks. If any damage is found, replace the affected cable immediately. Fourthly, ensure that the Romex cables are properly secured and supported as they exit the hole. Use cable staples or clamps to secure the cables to the surrounding structure, preventing them from sagging or straining. Fifthly, consider using a bushing or grommet to protect the cables as they pass through the hole. A bushing or grommet is a small, typically plastic or rubber, fitting that is inserted into the hole to provide a smooth, rounded surface for the cables to pass through. This can help to prevent abrasion and damage to the cable sheathing. Sixthly, be aware of the potential for condensation to form inside the hole. If the hole is located in a damp or humid environment, condensation can accumulate and potentially corrode the conductors or insulation. To prevent this, consider sealing the hole with a sealant or caulk that is suitable for electrical applications. Seventhly, if the hole is located in a fire-rated wall or ceiling, ensure that it is properly fire-stopped after the cables are installed. Fire stopping is the process of sealing any openings in fire-rated construction to prevent the spread of fire and smoke. Use a fire-rated sealant or caulk to seal the hole around the cables, ensuring that the fire rating of the wall or ceiling is maintained. Eighthly, when calculating conductor fill, remember to account for any other cables or wires that may be running through the same hole. The total cross-sectional area of all conductors must not exceed the maximum allowable fill percentage. Ninthly, if you are unsure about the proper conductor fill or installation methods, consult with a qualified electrician. A qualified electrician has the knowledge and experience to assess the specific situation and provide expert guidance on the safest and most compliant way to proceed. Tenthly, always prioritize safety when working with electricity. Follow all applicable safety procedures and use appropriate personal protective equipment. Remember, electricity can be dangerous, and even a small mistake can have serious consequences. By following these practical considerations and best practices, you can ensure that running Romex cables through holes is done safely and in compliance with electrical codes. Remember to always consult with a qualified electrician if you have any questions or concerns. Furthermore, consider the type of load being served by the 14-2 Romex. If the load is continuous, meaning it operates for 3 hours or more at a time, the NEC requires that the overcurrent protection device, such as a circuit breaker, be derated to 80% of its rated value. This means that a 15-amp circuit breaker, which is typically used with 14-2 Romex, should only be loaded to a maximum of 12 amps. If the load is non-continuous, the circuit breaker can be loaded to its full rated value. In addition to the ampacity of the conductors, it is also important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause appliances and equipment to operate inefficiently or even fail. The NEC recommends that voltage drop in branch circuits should not exceed 3%. To minimize voltage drop, use larger conductors or shorten the length of the circuit. The type of device that the end of the Romex conductors are connected to can have an impact as well. For example, if the conductors are connected to a dimmer switch, make sure the dimmer switch is rated for the appropriate amperage and voltage. If the conductors are connected to a receptacle, make sure that the receptacle is properly grounded and that it is rated for the appropriate amperage. The method of connecting the Romex conductors to the devices is also important. Use proper wire connectors and ensure that the connections are tight and secure. Loose or poorly made connections can cause overheating and electrical fires. The environment in which the Romex conductors are installed can also affect their performance and lifespan. In damp or corrosive environments, use conductors that are specifically rated for those conditions. Protect the conductors from physical damage by routing them through conduit or other protective measures. If the Romex cables are installed in an area where they may be exposed to sunlight, use cables that are UV resistant. Sunlight can degrade the insulation on Romex cables, leading to premature failure. Regularly inspect the Romex cables for any signs of damage or deterioration. Look for cracks, abrasions, or discoloration in the insulation. If any damage is found, replace the affected cable immediately. Also, be sure to keep the cables clean and free from dust and debris. Dust and debris can trap heat and reduce the lifespan of the cables. The labeling on the Romex conductors is also important. Make sure that the cables are properly labeled with their size, type, and voltage rating. This will help to ensure that the cables are used correctly and that they are easily identifiable in the future. The color coding of the Romex conductors is also important. The black wire is typically used for the hot conductor, the white wire is typically used for the neutral conductor, and the bare or green wire is typically used for the ground conductor. Follow these color codes consistently to avoid confusion and to ensure that the wiring is done correctly. Remember to always consult with a qualified electrician if you have any questions or concerns about the installation or maintenance of Romex cables. Electrical work can be dangerous, and it is always best to err on the side of caution. Furthermore, staying informed about the latest electrical codes and best practices is essential for ensuring the safety and reliability of your electrical systems.